All right, so on this one, it asks you to plot the following and describe the effects. So I'm going to make one gigantic graph here. We're going to pretend these are nice perpendicular straight lines. All right, if I just want to graph just Z, what's the coordinate of that? Okay, so I'm going to go 1, 2, 3, down 2. Here is my Z. I think I'll just call it A for now because that's the part that I did. Z minus 2. What is this minus 2 going to affect? The real. So what's its new coordinate? I can literally just take the real part, subtract 2 from it. So then I'll go 1, negative 2. And what did B do versus A? It went left how many? Left 2. I'm good with this. Your book will probably say left 2 on like the imagine or the real axis or something like that. So it'll say real axis. Just know that if it says left, there's what the direction you're going. What's this plus 4i going to do to the point? The imaginary. So what's its coordinate? Very good. So negative 2 plus 4 would be positive 2. So 3 comma 2. And now what did C do versus A? Not reflect. Oh, it does look like a reflection. You are correct, but it technically didn't reflect. It did, but if you would reflect, I would not count it wrong. But what did it really do? It shifted up 4, right? But it technically did reflect. So shift up 4. And again, they're going to call it the imaginary axis. I'm not too picky on that. If you went shift up or down, then I know what axis you're on. Now this right here, this is adding another complex to it. So it will affect the what and the what? The real and the imaginary. So what is 3 plus negative 2? 1. And then what's negative 2 plus 4? 2. So I get 1 comma 2 now. So this right here, technically the math is 3 minus 2i, because that's what my z is, plus negative 2 plus 4i. So when I combine like terms, 3 plus negative 2 gives me a positive 1, and then a negative 2 plus a 4i gives me a positive 2i. Okay. And then now what would you describe this from A to D? From A to D, what is it? Good. And then up 4. And that's really all I'm looking for. Again, if you want to go into more details of the imaginary axis, the real axis, that's fine. That's the basics I'm looking for. Questions on yesterday? All right, now the notes we took at the beginning of yesterday is basically what the questions are asking on part 2 here. And multiplying by I does what geometrically? Good. It's technically a rotation, but I got you if you said just 90 degrees. So it's a rotation, 90 degrees clockwise. Well, we need to get better with the mathematical. So it is moving. Rotate would be the correct term, just like shift up and down, left and right was the correct translation. So this is a rotation, 90 degrees counterclockwise. Make sure you don't say clockwise, because here's a little quick question. To go 90 degrees clockwise, I would have to multiply by the what? Negative what? Negative I. Negative I makes it go clockwise. A positive I makes it go counterclockwise. Ask your question. Yes, yes. All right. Taking the complex conjugate will do what geometrically? It will reflect. That's the key word. So rotation, reflects. I'm good with these two options here. I went with x-axis, but if you went with real axis, that is the same answer to me. So real or x-axis. Now here's the next question that a lot of y'all forgot, but we did write it down yesterday. What would cause it to reflect across the imaginary axis? What would I have to find? Good. The opposite, bless you, the opposite conjugate. I never just spell it. J, then Okay. It's also got another name. It's considered to be negative conjugate. Both of those will be the same thing. But if this right here is A minus BI for the complex conjugate, this is the negative A plus BI, where all I have to do is change the real part. Questions? Yes. And make it well, yes, but we're not going to get into that quite yet. But I could technically, I don't know if it has a title to it, but I could reflect the real and the imaginary, and it's technically reflect across the origin because it reflects across the y equals x. But I don't know if it has a name like the opposite conjugate or anything like that. But we can investigate when we get to that point. All right. All right. So now I want y'all to go into example 1, and we're going to do this one together. So we're still in our workbooks. And we're going to talk about today on how to multiply, or what does multiplying do to the complex number. So we're going to start here. We're going to do some investigation. It tells me we're going to plot the given points. Oh, trash. Where's my pen? All right, so let me choose black again to make my little graph here. We'll go with oranges. That's fine. Yeah, I use one graph would be probably best. All right, so it says plot the given points and then plot the image LZ equals 2Z. Okay, what this is basically stating, if Z1 is equal to 3, you are basically going to take this right here and make it what is 2Z1. Right? So this is a 2Z, Z1 equals 3. So this is basically just going to be what is 2 times 3? 6. This is example 1. So when you see LZ, that's the name of all of these mapping functions, and it says 2Z, you're going to take whatever Z is given to you, and you're going to multiply by whatever that number is. In this case, is a 2. What if it was 4Z? What would I multiply 3 by? 4, and so on and so on. So now I'm going to map this. So how do I graph 6? Okay, here we go. So I'm going to graph Z1, which was just 3, 0. There's my first point. That's Z1. You are correct, yes. I was testing you. Good job. Good job. All right, so this is my Z1. And then if I wanted to graph Z6, I would just need to go 3 more over. And what I'm going to call this, I'm going to do Z1 with a prime above it to indicate that Z1's got shift. Prime is like an apostrophe in English. So an apostrophe is a prime. Basically, it's the result of what I did to the original function. All right. So we see this. Everyone go with that? Let's look at one maybe a little harder. Z2 now equals 2i. What am I going to do to that 2i? I want to multiply by 2 because that's what it's telling me. It's telling me to do 2 times all these z's. So I'm going to do 2 times 2i. What's 2 times 2i? 4i. Bless you. So I'm going to start off by graphing my Z2, which was 2i, which how do I graph 2i? Up 2 will be 0, 2. This time I'll go to the right spot. So this is my Z2. And then 4i, what would I need to do? Go up another 2. So this is now my Z2 prime. All right, so that's its new effects. We good with that so far? All right, all right. I now have 1 plus I. What am I going to do with that 1 plus I? That's exactly it. I'm multiplying 2 to all my z's. So I'm going to do 2 times 1 plus I, and I'm going to distribute. And what's that give me? Very good. All right, so again, I'm going to graph it. I'll graph the first Z3. What's the coordinate for Z3? 1, 1. Very good. So I'm going to go 1, 1. So that's my Z3. And then 2 plus 2i would be 2, 2. Now I'm going to go over 2, up 2. So now this is my Z3 3 with a line over it. We're still good so far. Try and color code it so you can kind of see the comparison between them. All right, I don't have any room, so I'm going to write my D up here. D was Z4 equals -4 plus 3i. What am I going to do to that guy? Well, same thing. I'm just going to take the 2 and I'm going to distribute it out. And when I do that, what do I get? All right. So let's graph both of them. So my Z4, what's the coordinate for just Z4? You're right. So 1, 2, 3, 4, up 3, roughly right here. There's my Z4. And then now what's my coordinate of my new one? Okay. So now that's 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. All right. Questions so far? Pretty straightforward. All right. Let's look at E. So Z5 is equal to 2 minus 5i. So what would its new value be? Or how would I find its new value? Distribute the 2. Very good. And you get what? Very good. And what was the original point? All right. All right, so I start off by graphing 2 and then 1, 2, 3, 4, 5. Here's my original point. And then it went down to 6, 7, 8, 9, 10, over to 4. This is my Z5 prime. All right. Any questions there? Can anyone tell me what they see here? What did I do every single time? Geometrically. I moved. How so? I did move left, up, and right and down, but did I move the same amount left, right, up, and down? So what could I say in total that every single one of these did? It did shift, but how? How so? I like that. Did you notice that every single one of these doubled? They doubled in what? Length. Very good. So length, if I look at this Z4 one real quick, since it's kind of like isolated over here, here's my vector as a perfect straight line. And then if I drew another vector, are these two vectors the same? Yes, I basically just doubled the vector and got myself in a new spot. So when we're multiplying complex numbers geometrically, it is going to be multiplied by some scalar factor. In this case, it is doubled. The word here that you'll see a lot is a dilation. Dilation just means it changes it either bigger or smaller. So notice when I did all the shifting left and right, I just moved a value left and right. But here I'm multiplying each value. So I'm either doubling it, tripling it. I could multiply it by a fraction. I could half it. I could third it. But I'm changing the size of the length of that vector. Right? So that's the big takeaway. So what I want you to do is go into the exercises, and I want you to do 1 through 5. What happens then if I multiply by an imaginary number rather than just a real number? Play around with it. IZ is the same thing as 2Z. What do we do with 2Z? So what are you going to do with the I? It's just a 1I, yeah. What does the Z represent? What did the Z represent on what we just did? It was telling you that for each one of these Z values, that's what you're going to do to it. Does everybody have all this? Can I erase this? Two I squared. What is two I squared? What's I squared? So therefore, what's two I squared? There you go. You're pretty good at answering your own question. It's all right. That's why we review. I never expect you to be perfect. Oh, yes. Yeah. I didn't catch that first part. Have we already finished the first one? What's the first one? Yeah, perfect. All right. What's the coordinate of 3i? This is what y'all got graphically for that first one. Did you originally start there and then land here? Okay. What's the coordinate for 2i? Okay. Keep it going. And y'all found out when you multiply 2i by I, you got what? -2. And that coordinate is? Very good. Bless you. You see a pattern with those first two? What's the pattern you see with the first two? Does anyone have a pattern? Okay. And then on the other one, it's vice versa, right? So is that the only pattern everyone sees? If I go from this green to this purple and this black to this red, it's counterclockwise. How much? 9 degrees. And we know that because what do we know by multiply I does? We know it's going to rotate it 9 degrees counterclockwise. So you can kind of see that with these two because it looks pretty easy, right? This is here, that's 9 degrees. We know that. It gets a little harder when you get to number 3. What's number 3's coordinate? The original, yes, ma'am. Okay. When you multiplied it by I, what did it become? Very good. She got -1 plus I, which is -1, comma 1. Did anyone not get that? Do I need to show that? All right. So now when I do this, I'll call this Z3. It's not as easy to tell since I'm kind of in the middle, but could you technically still see maybe a 9-degree turn? Can anyone tell me what? Oh, I gotta draw on this. Anyone tell me what this degree is by chance? Does anyone know what this degree is? 45 degrees. Okay. Can anyone tell me what a straight line is? 180. So could anyone tell me what this degree is? 45. So if I know this whole thing is 180 and this is 45, what would be this degree from here to here? And how would I find it? 180 minus 45, which is 135. What is 45 plus 90? 135. So there's your geometric rotation there. So you might not be able to easily have seen that this rotated. This would probably look at like a what to you? A 180, but a reflection, right? Almost looks like a multiplying by the negative conjugate or something. But in general, this is actually going to be a rotation of 90 degrees. Go ahead. Yes, ma'am. All right. Keep it going if you haven't finished already. So I want you to see that. What's the fourth's original point? All right, so there I am right there. So there's my original point. Did everyone's original point kind of go right there? Okay. What is the new coordinate after multiplying by I? Okay. Does anyone need to see that math algebraically, or did anyone get that? Okay. So this would be my Z prime 4. Again, here you might not as easily seen that this is also going to be a rotation, right? But if we do some math here, do some mathing. You don't know this. You'll find this out in a couple of days. Probably by next week, really. This right here is actually 101 degrees. And if I add 90 more to that, this makes a 90-degree angle. So making that 191 degrees. Right? You don't know that yet, but you'll see it later. You'll actually be able to calculate this using our trig stuff. Right? But that one, not as easily able to see. You might not know your angles yet. All right. Any questions on that one? All right. We did do a fifth one, so let's make sure you got that right, and then we'll move on. What's the original point of 5? All right. We'll call this Z5. All right, so you see I landed way over here. And then now, what was the new coordinate after multiplying by? Very good. 5, comma, negative, a positive 2? Yeah. And again, you can see that I was here, landed here. This would actually make a from here to here. Pretend those are straight lines, but that makes a perpendicular line, which makes this 90 degrees. So it changes from one end to the other end. All right, but we'll talk about how to calculate that soon. All right, but let's move on to questions 6. And let's talk about what we just found out. So what is the geometric effect of the transformations? What did we see? What specific rotation? And then we went from 45 to 135, we went from 0 to 90. Very good. We saw a rotation 90 degrees counterclockwise every single time. So when multiplying by I, we have a rotation. And when we multiplied by a real number, we had a dilation. All right. So you have 3 different types. So we'll add this all together. So a rotation. So, okay. So let's put this in more of words. So this might be somewhere good to add a note, start, whatever you want to do it. When we add it or subtract it, real or imaginary, we had this thing called a translation, which we used the word shift. And it either shift, can y'all see that in yellow? Let me change in colors here. Do I need to rewrite it? Add, subtract, real, imaginary. And it was a translation in which it shifted. And we saw shifts of up, down, left, and right. So that's what we saw yesterday. Today, we have seen if we multiply a real number, we get a dilation. A dilation basically ends up either growing it or shrinking it. So we saw on our example that everything got doubled, but if I was to multiply by half, I would see everything get shrunk by half, right? So that's what happens when we multiply by a real number. And then what you just now saw, if you multiply a imaginary number, we get a rotation. Now, it's not necessarily always going to be 90 degrees, because what if I multiply everything by I squared? What would I get? I would rotate 180 degrees. I would get -1. So I get a rotation of 180 degrees, but then it becomes a real number of -1. So it's also can be considered a reflection or a dilation in the opposite direction. It's bigger or smaller. So think of it like this: a translation, I just shift; a dilation, I get smaller or bigger; and then a rotation, I literally rotate. Those are your 3 types of transformations. Dividing is the same thing as multiplying by a fraction. So it depends on what you're dividing by. If you're dividing by a real number, you're still multiplying a real number just in a fraction form. So like for instance, if I divide it by 2, I'm still multiplying by 1/2. Vice versa, if I'm dividing by if I'm dividing by I, if I do the multiple of inverse, I'm technically multiplying by negative I. So I'm still going to have a rotation. Question? Oh, we got plenty of time to do more questions. All right, so then the number 7, it says, is LZ a linear transformation? And explain yes or no. Do y'all think this is a linear transformation? LZ was just our basic values of IZ, 2Z, all these different ones. All right, so let's say, let's go with the IZ, because that's gonna be the funnest one to do. What are the two properties it has to pass to be a linear transformation? The additive and multiplicative. So that means if I find x plus y, I replace this z with an x plus y, the I will stay there. What would I do in this situation? Yeah, this is the additive. I replaced my z with x plus y, and I'm trying to find out if this does in fact give me lx plus ly. So this is the name of the function. This is what I'm replacing the z with. So I'm trying to prove this. I'm trying to prove this lx plus y equal lx plus ly. All right, but I can't just state that. I have to show that. So what I did is I'm replacing this z with an x plus y. So what would I do next to simplify this? No. I have an I on the outside. What do? I need to distribute. So when I distribute, I get ix plus iy. Well, what would ix represent? Just lx. And what would iy represent? ly. So you just proved that the additive property does work for this linear transformation. The next one you need to prove is the k. Now, you don't have to choose a value of k. You can just plug a value of k in there. So if I plug in a k, I see that I'll get an I times kz. And notice the multiplication of the commutative order of multiplication. What's going to happen to the I and the k? What can I do there? I can just flip them. So I can do k, iz. Well, what's iz? Yes, that's lz. Very good. All right, so I just showed that this is also going to work for the multiple property. So, k times lz. Oh, L of z. All right, and that's a great place for us to stop. Y'all did really good today. And we'll continue our discussion. So no problem sets unless you want to do any of them for extra credit. Those will be due on Monday. There's like 6 of them.